Stationary points are something that you should be familiar with from National 5. In National 5, we tended to call them turning points. So you should know about minimum and maximum turning points. Now you need to also know about rising points of inflection and falling points of inflection. So this technique that we're going to be using is very important. You'll see that in the next 3 or 4 lessons, although they're got different titles, you are essentially doing the same thing over and over. So it's really important that you understand the steps in the process that I'm about to work through. So if we want to find the stationary points and determine their nature, first thing we have to do is differentiate our function. So we need to find dy by dx. If I differentiate that function, I get 12x cubed minus 24x squared plus 12x, and then that one drops off. That's our first step. Our second step, we have to make a statement. Now this is what some of us would call a star statement. So our star statement is at SPs, so SPs stands for stationary points, dy by dx equals 0. So when you think about a turning point or a stationary point, they happen when the gradient is 0. So that's where they are turning. So it's as if they come down to a certain point, they stop, and then they travel back up. Or they go up to a certain point, they stop, and then they travel back down. So we already know that if you differentiate a function, substitute in an x value, you get a gradient. So what we are saying here is that our gradient is equal to 0. Step number 3 is that we're going to go on to find our x coordinates. So to do that, we need to set our derived function equal to 0. So all of that equals 0. And then we're going to have to factorise. So remember, when you're factorising, there are different steps. So first thing that we have to look for is a common factor. I've got a common factor of 12x and all of that, so we can take that out. We're then left with x squared minus 2x plus 1. Now look how much easier that is in comparison to step 3. So it's really, really important that you do look for a common factor first. So we can then go on to factorise it properly. So that 12x stays where it is. It has to stay there because we've got this x value. So that would be equal to 0. We then split this into 2 brackets. We've got our x and x. To make 1, we've got 1 and 1. And to make that negative 2, we're taking them away. And all of that's equal to 0. So step 5, we then have to solve that. So either 12x equals 0 or x minus 1 equals 0. In this case, x would be equal to 0, and in this case, x would be equal to 1. So that curve has got stationary points when x is equal to 0 and when x is equal to 1. So step number 6, we're going to determine where the points happen. So we know that they happen when x is 0 and x is 1, but we need to know the coordinates of that. So when x is equal to 0, we need to find y. So looking back to your original function, which is this one here, and that's very important, you always have to go back to your original function now. This derivative is only there to help you calculate your x values. Once you've got your x values, you can then go back to this to find your y values. So we've got 3 times 0 to the power of 4 minus 8 times 0 cubed plus 6 times 0 squared plus 1. All of that would cancel out to 0 with the exception of that 1. So we've got a coordinate of 0, 1. So we have a turning point or a stationary point at 0, 1. Right now we don't know if it's maximum, minimum, rising or falling points of inflection. We also know that x is equal to 1. So we're going to do the same thing. So we've got y, 3, 1 to the power of 4 minus 8, 1 cubed plus 6, 1 squared plus 1. So this is going to give us 3 minus 8 plus 6 plus 1. So 3 minus 8 is negative 5 plus 6 gives us 1. Add on 1 gives us 2. So we've also got a stationary point at the coordinates 1, 2. So x coordinate 1, y coordinate 2. So part 7, we now know where our stationary points are. However, we need to know the nature of them. Okay, so for our nature, we do what we call a nature table. So your nature table is split up into 3 rows. So you've got your x row, you've got your dy by dx row, and you've got your slope row. Now, the number of columns in this depends on the number of x values that you get. So I tend not to put my columns in. Sometimes you'll find you've got one x value, sometimes you could have two. Depending on your curve, you could have 3, 4, 5. So I'm going to leave my columns, but I am going to write in my x values. So my x values I found over here, I'm going to put them in numerical order. I've got 0 and 1. Now, this is very, very important. You are then going to find the nature by substituting in values that lie less than, between, and more than these values. So you're going to substitute in a number that's less than 0, and you're going to substitute in a number that's greater than 1. You're also going to substitute in a number that lies somewhere in the middle of that. Now, that's very important. You cannot substitute in 0, because if we substitute 0 into dy by dx, we get 0 out. If we substitute 1 into dy by dx, we get 0 out. And that is because they are flat. They are stationary points. Okay, so these columns here will always look like this. The only thing that will ever change in the columns is your value for your x. Now, when you're substituting in numbers either side of these, it can be any number that you want. Obviously, the smaller the number you choose, the easier it's going to be. You can do working for this, and obviously if it's in a calculator paper, you can use your calculator. So here, where I've got my arrow pointing less than 0, I'm going to substitute in -1, and I'm substituting it into dy by dx. So remember, this up here is dy by dx. So because I've not got enough space, I'm not going to write it in, but I am going to talk through it. So if I substituted in -1, I would have -1 cubed, which would give me -1, and that bit there would give me -12. I would have -1 squared, this part here, which would give me a +1, so I would be taking away 24, and I would have -1 times by 12, which would give me -12. So all of that would give me -48. Now, it doesn't matter that it's 48. What it does matter is that it's a negative value. So in here, when we put in any number less than 0, we are going to get a negative result back out. So I've got a little negative sign and then a VE for negative. So if you tried that with -16, if you tried it with -100, if you tried it with -500, you would always get a negative value out. So when we're talking about our slope, that means you're going to have a downwards line. Okay, so the curve starts here and it goes down to where it stops. We then need to figure out what's happening after that point. So now we need to sub in a value between 0 and 1. So I'm going to substitute in a half. Now notice that I'm not writing these numbers down. That is because you could get thousands of options here. So you never write a specific number down, but obviously you can type a specific number into your calculator or try a specific number. So I'm going to try a half, but I'm not writing it down. So this one I need to do a little bit working for. If I have a half cubed, so 1 cubed is just 1, 2 cubed is 8, and I'm timesing that by 12, so I've got 12 over 8. I'm then taking away a half squared, which is 1 over 4. I'm timesing that by 24, so I end up with 24 over 4. And I've then got a half of 12, which is 6. Now, if I work through this, so obviously I need a common denominator for this, or I can simplify it by seeing that 24 over 4 is going to be 6. So I've got 12 over 8, take away 6 plus 6. These would cancel each other out. It doesn't matter that it's 12 over 8, but it does matter that it would be a positive 12 over 8. So this bit in here is giving me a positive value, so my slope goes up the way. So that means that the next part of my curve continues to go up until it reaches its next stationary point when x is equal to 1. So the final thing we have to do is figure out what's happening beyond 1. So we're going to be substituting in 2 for this part. So again, I need a little bit of working, or you could put it into your calculator. So over here, if I do 2 cubed, 2 times 2 gives me 4, times by 2 gives me 8. So I've got 12 times 8, which is 96. Over here, I've got 2 squared, which is 4, times by 24, which is also 96. And then I've got 2 times by 12 gives me plus 24. Again, we're quite lucky with these numbers. The 96 and the negative 96 cancel out. And I've got a positive 24. So this part here is going to be positive. Now remember, any number above 1 that you substitute in, even 1.1, you are going to get a positive value back out of there. So that means we continue to rise. So our graph starts here. It goes down to a minimum turning point. It goes up to the next turning point. And instead of turning back down a little bit new and higher, it continues to then go up. So we've got a stationary point down here and we've got a stationary point down here. So for our final section, so for part 8 of this question, you have to write out your nature. So when we had an x coordinate of 0, we calculated a y coordinate of 1. And we know that that is going to be a minimum turning point. So 0, 1 is a min TP. When we had an x coordinate of 1, we calculated that we had a y coordinate of 2. And this is a rising, so RPOI for rising point of inflection. Okay, so that final step is very important. It will gain you a mark. You have to make sure that if the questions asked you to determine the nature, you have to explicitly state your nature. Okay, so that question has got a lot of work into it. These are worth a lot of marks, and as I said at the start, this process comes up for the next couple of lessons, so it is really worthwhile getting your head round it. Write out your steps separately. Do whatever it is that you need to do to make sure you've got this, because this will get you a lot of marks in the final exam.